Okay, let's continue to study for the Unit 3 exam. And so now we want to talk about radius. So this is going to be the radius r of the star. So how can we do that? So this particular formula here in the yellow box comes when you take the photometry equation and you combine it with Stefan's law. Now you don't need to worry about how to do that, but when you take those two equations and you put them back to back and then you solve it for the letter r, you get that. And so it's going to be equal to the square root of the brightness of the star and then divided by 4 pi times a fundamental constant of nature, which you don't need to worry about, and then the temperature of the star raised to the 4th power. So we could write it like this if we wanted to. We could say r is proportional to the square root of L divided by t to the 4th. So we get rid of the 4 pi thing and then get rid of the sigma thing. The sigma is this thing. So it looks kind of like a 0, but it's not. And so that's a fundamental constant of nature. So the formula is basically this thing right here. So I could tell you that, for example, that the brightness of a star doubles what happens to its radius. So you would, instead of L, it's going to be 2L because it's going to double. And then you might be tempted to say that the radius is going to double, because so far in here we've been saying that if you double this side, you got to double this side over here, but it's a square root thing. So it's going to be the square root of 2. So that the radius is going to increase by the square root of 2. Okay, then other properties of the star using its spectrum. So again, this was by looking through the diffraction grating. You would look at all the different colors of light produced by the star, and then from that you could figure out all of this other information. Don't worry about it. You were tested on this in unit number 1, so you're not going to be tested on it again. So this might be something that you should be able to do. So this chart here is a flow chart. So on the left-hand side is what you start with. You've got a stopwatch. So you are able to measure the period of a binary star system. Okay, then you are also able to measure its parallax angle. You are able to put a photometer on your telescope, so you know what the F is. You are able to put a diffraction grating on your telescope, so you are able to measure its spectrum. So that's the raw information that you start with. Then the question is, what do you do with that data? And so in class, what we did was we took our 5 equations down there at the bottom, and we used those equations instead of the question marks. So there's 5 question marks, and then there's 5 equations, and in class we figured out where we would use each of those equations. So something like that could be on the exam, where it could be matching. And so we did this in class and showed which equation to use in order to calculate which part of the chart. All right, so this shows what we have measured. So after measuring thousands of different stars, there's the range in colors, there's the range in brightnesses, there's the range in temperatures, there's the range in radiuses, there's the range in masses. Wouldn't it be nice if all that information was on one chart? It is. So this is called the HR diagram. Gotta know it inside and out. So I'm going to give you one of those on the exam, and then I could tell you the temperature of the star that I'm interested in, and then you give me all of the other properties of that star. So what kinds of properties? Okay, you'll notice that vertical is the brightness of the star compared to the brightness of the sun. Now, remember on the exam, let's say that you read it off the chart and it's 100. Don't just write 100. So you're going to want to write 100 L and then put a 0 next to it. Or you could say L sun. Or you could just say 100 times the brightness of the sun. So any way that you want, but you need to say that you don't just give me the number, tell me what the number means. So it's 100 times the brightness of the sun. Okay, the horizontal information is going to be the temperature of the star, the color of the star, and then the spectral type, which you don't need to know for the exam. And then the diagonal, there's diagonal lines on that chart, kind of hard to see, but the diagonal lines are telling you the radius of the star compared to the radius of the sun. So if you put down 10, don't just say the number 10. You're going to want to say 10 times the radius of the sun. Or you could say 10 and then R sun, or you could say 10 times the radius of the sun. So don't just put down the word 10 on the exam. And then there's other information on the chart. So you'll notice there's some things that are in purple, and then those are the mass of these stars in comparison to the mass of the sun. And then in green, it tells you how long is the star going to live. So on the exam, I could do a question like this, where I give you the name of the star, and I'll even point to it on the HR diagram. And then you tell me all the properties of that star. So for example, Spica is a star that's up there at the top, and you're going to tell me all of its characteristics. Another thing you should know is the regions of the HR diagram. So you should know where the main sequence is and what does it mean. What are the objects that are in the upper right hand corner, and what are they? And then also, what are the things that are in the lower left hand corner of the HR diagram? All right, and that's it. So that is this lesson. And so we're going to take a break, and when we come back, let's talk about the next lesson that's going to be on the Unit 3 exam.